Theorem 28 is a two-parter as well. We'll quickly cover the first and then cover the second part, which is just its converse. Every point in the bisector of an angle is equidistant from the sides of that angle. And so remember, we have to recall and bring back to memory the definition of distance. And we've learned the distance between 2 points, which is just a straight line joining the 2 points. We've learned the definition of distance between a point and a line. And that's just literally the perpendicular drawn from the point to the line. It's perpendicular to that line. And so we got to remember that we're talking about equidistant, so they have the same distances from this point to both sides of the angle. And so we're saying if this point is equidistant, or I should say this point is in the perpendicular. Oh man, I'm already talking about the last theorem in corollary. If we have a point in a angle bisector, it will be the same distance apart from each of the sides. And the converse is stating that if we have a point equidistant from the sides of an angle, it is or it lies in the bisector of that angle. So we're given this angle BAC and bisector AG with a point inside that bisector P. Well, again, we could pick any point on that bisector and it'd be true. And then we're trying to prove that P is equidistant from AB and AC. All right, so let's jump on in. Number 2, we already wrote our given down in number 1. Number 2, we're going to draw PD and PE perpendicular to AB and AC respectively. That's just us using our definition of distance there. That's not necessarily the reason why we can do that. The reason we can draw PD and PE perpendicular to those lines is that one and only one perpendicular can be drawn to a line from a point outside, oh my, outside the line. Okay, number 3, we've talked about that many times. Don't need to waste any time talking about that. Number 3, we can say that angle DAP, I don't have a D here. Oh yes, I didn't draw my auxiliary lines. So let's do that here. And I got my auxiliary line here, and I said that these were perpendicular to AB. So let's make those perpendicular. And let's just actually call these by numbers. I'm going to call that angle 1, that angle 2. I'm going to say that angle 1 equals, man, I see where I'm going. Let's call this angle 3 and angle 4. Okay, and I'll call this ABCD, I'll call this D, and I'll call that E. So angle 3 equals angle 4 because we've stated that this line segment is a bisector. AG is the bisector. So that's just the definition of angle bisectors. All right, number 4, I can say that PE and PD are distances from P to the sides of the angle. Definition of distance, obviously between a point and a line. Number 5, AP equals AP identity. So we've got this line equaling that line itself. We have this angle equaling this angle. And so we can now say something about those angles that we just drew, angles 1 and 2. Number 6, we can say angle 1 and angle 2 are right angles. Definition of perpendicular lines. We talked about them being already perpendicular up here. So we can say that those are right angles. Number 7, we can state that triangle AEP and ADP, triangle ADP, are right triangles. Definition of right triangles. And so I hope by now we can start to see that proofs aren't too difficult. We use a lot of the same reasons in a lot of these, and obviously I'm trying to we're using corollaries and theorems that we've already learned. It's impossible to build on things if you don't have a good foundation. So as we keep working through, we use things from the past, and we just keep working and we keep using those things, and the more tools we get, the easier the proofs may get. The hardest thing is to keep in mind all of these theorems, postulates, axioms, all this stuff. If you forget them and you don't review them, you can't use them. If you forget that you have a tool in your garage, you can't really use it. You have to be like, oh, that would have made my job so much easier. I can't believe I cut my lawn with a pair of scissors when I had a lawnmower in my garage. So you got to remember that you have these tools. You have to review and go over them so that you can use them in the proofs. Number 8, we can say now that triangle AEP is congruent to triangle ADP by hypotenuse angle. Let's take a look up here. We've said that they're right triangles and they both have equal acute angles there. We also stated that they do have the hypotenuse there. That's the side opposite the right angle. So there we go, hypotenuse angle. And number 9, we can say PE equals PD. Number 9 by CPCTE. And so there we go. These two distances, we said in the proof that those are distances. Those distances are equal to each other. So P is equidistant to the sides of the angle. Let's quickly talk about the second part of this theorem, that if a point is equidistant from the sides of an angle, it lies in the perpendicular bisector. Very similar kind of process. Let's just quickly walk through it. We're going to draw PD. That's not right. We already have it drawn, so let's take a quick look. We're going to draw a line, though. A line from A through P to G. From A through P to G. PE. Oh, we should probably state, and I hope we can know what I'm about to write down. 2 points. Determine a straight line. Number 3, PE and PD are perpendicular to AC and AB respectively. In the given, we are told that they are equidistant. And remember, again, those definitions are key. They are equidistant, and so we know that if we are talking about distance from a point to a line, it involves perpendiculars. And so P is perpendicular to AB and AC respectively. And so we can say on number 3, PE and PD are perpendicular to AC and BAB, respectively. Number 3, definition of distance from a point to a line. Number 4, we can say angles, and actually I'm going to label these here. I can say angle 1, angle 2. I can say angles 1 and 2 are right angles. Number 4 here, the reason, definition of perpendicular lines. Number 5, AP is equal to AP. Identity. Let's make our markings here. There we go. That is our right angle. That is our right angle. And then we can say number 6, triangle. That's not a triangle. Triangle AEP and triangle ADP are right triangles. Definition of right triangles. Number 7, they are now congruent to each other. Triangle AEP is congruent to triangle ADP by hypotenuse leg. Have the hypotenuse equal to itself. They both have the same side, which is the hypotenuse of each, and we have a leg equal in both. So hypotenuse leg. And then number 8, angle PAE. And so let's just label these ones here. We can say 1, nope, we can't say 1 and 2. We can say, I'll call that 4 since I already did that. Angle 3 and 4 equals each other. Angle 3 equals angle 4 by CPCTE. And number 9, I can say AP bisects angle BAC. Definition of angle bisectors. And so we can say that this line bisects this big angle because it cuts the angle into 2 equal parts.